going to revisit energy. Come on, energy was fun. Alright, the equation we came up with before, where work was equal to the change in potential energy plus the change in kinetic energy. This equation, though we didn't specifically state it at the time, this equation's not quite complete. This equation doesn't take into, well, we've swallowed up any work done by friction, for example, that heats things up. We swallowed that up in the work term. Okay? It turns out there's another way to change energy besides just mechanical work. This is called mechanical work. When you have an actual physical force moving an object, that's mechanical work. But energy can be exchanged and changed in other ways as well. For example, if I had brought a glass of ice water and set it on the table for class today, by the end of class, most, if not all of the ice would have melted. Well, that means we changed the energy of the molecules. We increased their kinetic energy. We didn't change the overall potential energy because it's not like I was raising and lowering the glass or anything. We didn't do any mechanical work because there weren't any forces applied to it, making it move. So there had to be some sort of other energy source to increase the kinetic energy of the molecules, to make it melt. This type of energy is called heat. Heat is a transfer of energy into or out of an object, just like work is. Work is the transfer of energy by physical means. You're applying an actual physical force, making things move. For example, if I had a glass of water and I wanted to do work to make the water warm up, what could I possibly do? That wouldn't be work.
You shake it vigorously enough, the friction inside of the molecule.
Certainly, you could shake it vigorously enough, apply some forces, make them physically move. That would be one way, certainly.
Pressurize it.
But it depends upon how much you compress it by, the volume.
But it will heat up.
But yes, yes. So pressurize it somehow, exert some sort of force on it, that would work. What if I took a spoon and I stirred it?
Yeah.
Sure. So as long as you somehow apply some sort of force and make those molecules move around, that would be work done. But if all I did was set it on the table and let it sit there for the class period, it would still get warmer. But no work would be done in that case. The work is not the work. The energy is being transferred by what we call heat. Heat is a transfer of energy due to temperature differences between the surroundings and the system. So the system would be the glass of water. Since the glass of water would initially be colder than the room is the surroundings, energy from the room, all the molecules moving in the room, would in turn transfer some of their energy into the water, thus melting the ice, increasing the temperature of the water. So heat and work are both ways to transfer energy. They're just by different processes. Both can result in changing a temperature. But they differ in terms of how that energy is transferred is all. Okay. Now, to separate out kinetic energy as a whole, the 1/2 mv squared of the whole entire object, versus the kinetic energy of the individual molecules, we tend to leave the delta K as the macroscopic kinetic energy, so the overall 1/2 mv squared because your whole system is moving. And we include the kinetic energy of the individual molecules as what we call the thermal energy. So that delta E thermal is basically, fundamentally, it's the kinetic energy of the individual molecules within your material. We didn't worry about this before because we didn't really worry or consider whether or not a ball rolling down a hill would be warmer by the time it was at the bottom than it was at the top. The temperature changes really aren't significant enough for that to be of concern. As we talk about gases, though, when we talk about gases specifically, this is going to be much more important. Okay?